Hello and welcome back. Today we will have lecture 4-2 on behavior-based control or behavior-based architecture. Behavior-based control and reactive control are often confused, so I want to go over some of the main differences. One of the differences is that behavior-based control uses behaviors while reactive control uses rules. Rules are less powerful than behaviors. Behaviors may be time extended and they may change based upon the sensory input. Another key difference between behavior-based and reactive control is that there is a representation. In behavior-based control, it's a distributed representation, and in reactive control, there is no representation. Another key difference is that in reactive control, the system maps between actions and conditions, while in behavior-based control, the designer maps between the conditions and actions. Also, behavior-based control has parallel concurrent executing behaviors with no central arbitration. So what are some of the objectives of today's lecture? One of them is to describe and define behavior-based control, and also to describe behaviors as well as emergent behavior, and to talk about the different types of behavior arbitration. Behavior-based control is also called think the way you act. It incorporates the best of reactive systems but does not involve a hybrid solution. Behavior-based control is inspired by biological systems. It is inspired by the fact that reactive systems are too inflexible and incapable of representation, adaptation, or learning, and that deliberative systems are too slow and cumbersome. Hybrid systems require a complex means of interaction among the components, so behavior-based control is the next best solution. It is the closest to reactive control and the farthest from deliberative control. Behavior-based control has the same capabilities as hybrid control. Behavior-based control acts reactively and deliberatively, where it's built on layers but no intermediate layer. It has a uniform representation and a time scale. Behaviors are concurrent processes that take inputs from sensors and other behaviors and send outputs to the robot's actuators or other behaviors to achieve some goal. Thinking performed through a network of behaviors uses distributive representations. It responds in real time on the reactive layer and allows for a variety of behavior coordination and mechanisms. Behavior-based control and hybrid control are the dominant control paradigms in robotics. Behavior definition. Behaviors achieve or maintain particular goals, such as homing or wall following. Behaviors are time extended and not instantaneous. They may take some time to achieve and or maintain their goals. They can take inputs from sensors and also other behaviors. Behaviors can send outputs to effectors and to other behaviors. Behaviors are more complex than actions. A reactive system may use simple actions like stop, turn right, etc. Behaviors may be things such as find object, follow wall, get recharged, hide from the light, etc. They are designed at a variety of levels of detail or descriptions. This is called their level of abstraction. To be abstract is to take details away and make things less specific. Behaviors can take different amounts of time and computation, and they are flexible, which is one of the advantages of behavior-based control. The power and benefit is also in the way they are organized and put together in the control system. A primitive behavior is composed of only one perceptual schema and one motor schema, so there is no need for a coordinated control program. Primitive behaviors are monolithic, that they only do one thing and are programmed as a single method. Behaviors assembled from other behaviors or that have multiple perceptual schema or motor schema are called abstract behaviors. A behavior puts the percept by the perceptual schema in a local place where the motor schema can get to it. Action selection. Action selection is the process of deciding among multiple possible behaviors when they are not mutually exclusive. Command arbitration is the process of selecting one behavior from multiple candidates. Command fusion is the process of combining multiple candidate behaviors into a single output behavior for the robot. Reactive systems must support parallelism, and the program must be able to multitask. Behavior arbitration versus behavior fusion. Behavior arbitration is picking one behavior or action, kind of like a multiplexer. Behavior fusion is combining multiple behaviors or actions, such as summing or adding them together. Arbitration-based behavior coordination is also called competitive behavior because candidate behaviors compete, but only one can win. In a fixed priority hierarchy, the behaviors are pre-assigned priorities, such as by which one is most important to execute, such as stability when the robot's moving. In a dynamic hierarchy, the behavior priorities change at runtime based upon the goal or task that the robot is currently working on. Subsumption architecture uses a fixed priority hierarchy of behaviors. Some hybrid systems also employ fixed priority hierarchy. Behavior fusion is the process of combining multiple possible candidates into a single output action or behavior. Behavior fusion is also called a cooperative method because it combines outputs of multiple behaviors to produce a final result. This result may be an existing behavior or a new one, which is where we get emergent behavior from, which is one of the benefits of behavior-based control. There could be weighting or have some logic in the system to prevent certain combinations and outcomes of behaviors as well. Emergent behavior. The reactive movement involves a robot running a very small set of behaviors which were combined internally to produce an overall emergent behavior. All robot behaviors result from the interaction of the robot's controller and the environment. So if these components are simple, then the resulting behavior may be predictable. However, if the environment is dynamic or the controller has several interacting components, then the resulting robotic behavior may be a surprise. If there is an unexpected behavior that is observable and useful and has some structure, pattern, or meaning, we call it an emergent behavior. Here is an example of combining behaviors to create an emergent behavior. So let's say we have a potential field method that has an obstacle that repels any robot that gets close to it, and we have a goal that attracts any robot that gets close to it. So if you combine these two things together, it's a very simple emergent behavior of goal to goal or move to goal. An example of a wall following emergent behavior is if you have a robot here that has two whiskers, and if the rules are, if the left whisker is bent, turn right. If the right whisker is bent, turn left. If both whiskers are bent, back up and turn left. Otherwise, keep going forward. You've never explicitly defined wall following. You've just defined rules about what happens when a whisker is triggered by the environment. However, based upon these very basic behaviors, the robot will follow a wall, although the robot knows nothing about walls and it has no explicit wall following behavior. In emergent behavior, we say the whole is greater than the sum of its parts. Emergent behavior appears to produce more than what the robot was programmed to do. We get more than we built in or something from nothing. Roboticists sometimes exploit this potential to design clever and elegant controllers. In particular, reactive and behavior-based control systems are designed to take advantage of such interactions or emergent behavior. Different control architectures affect the likelihood of generating emergent behavior in different ways. Reactive and behavior-based systems employ parallel rules and behaviors which interact with each other in the environment, which provide the perfect foundation for exploiting emergent behavior. Deliberative and hybrid systems do not necessarily have parallel interaction and would require environment structure and thus minimize emergence. However, of those two, I could see hybrid before deliberative because the hybrid system does have a reactive layer.